One of my favorite ways to prove something in math is the proof by contradiction. To prove something by contradiction, we begin by assuming that that thing is false. Then, using that assumption, we arrive to something that can never be true, meaning that our assumption was wrong in the first place. In this example, our friend here is trying to prove that Attack on Titan is the greatest anime of all time. So he'll begin by assuming that it's not, and then arrive to an impossible conclusion. Okay, maybe not impossible. Let's move to a more concrete proof to see how this applies. What we're trying to prove here is that there is an infinite number of primes. We start by assuming that that statement is false, so there is a finite amount of primes. Let's list them here. See what I did there with primes? Anyways, let's treat these guys as prime numbers. Now, if we multiply those numbers all together, the number we get is obviously not prime since all of our prime numbers divided. Alright? But let's add 1 to that number. Now, none of our prime numbers divides n. So n has to be prime itself. But n itself is not part of our group of primes, which contradicts the fact that all the primes are in our little list up there. So no matter how many finite set of primes we have, we can always find a prime that is not included in that set. So we can conclude that there's an infinite number of primes. Here's another beautiful example of where proof by contradiction is applied. The 5 boys and 5 girls problem. Actually, the original problem is 25 boys and 25 girls, but I don't have the energy to draw that amount of people, so please forgive me. So here's the setup. So we have 5 boys and 5 girls sitting around a table. We want to prove that it's always possible to find a person, both of whose neighbors are girls. Note that that person could be a boy or a girl. So like before, we start by assuming that this is false. So that there is an arrangement where no one is sitting between 2 girls. Take some time to convince yourself that this is in fact the opposite of our original statement. Let's draw that arrangement here. For now, we're not going to differentiate between boys and girls to keep things simple. We're going to label each person with a number from 1 to 10, like so. Now what we're going to do is move those people to smaller round tables, such that the people with odd numbers are on one table and the people with even numbers are on the other. Note that for the odd table, for example, we can't have 2 girls sitting right next to each other. Because if that was the case, then they would be arranged like so in the original table, which shouldn't happen by our assumption that no one is sitting between 2 girls. Similarly, on the even table, we can't have 2 girls sitting right next to each other either, for the same reasons. That means that there can only be at most 2 girls on the left table, probably rearranged like so, maybe with different numbers. And the same thing applies to the right table. We can only have at most 2 girls there as well. So that means that there is at most 4 girls in this group. But that contradicts the fact that we stated originally that there were 5 girls in the group. So we arrive to something that is obviously not true. So we can then conclude that in this group, it is always possible to find a person, both of whose neighbors are girls. That's it. Thanks for watching. Follow for more visual proofs.